All right, so what we're going to be talking about in today's lesson is how to simplify, multiply, and divide rational expressions, with those rational expressions being polynomials, in order to determine some horizontal and vertical asymptotes. All right, so first things first, we have to remember how we actually simplify rational expressions or simplify fractions. Okay, so the very first thing we had to do was we have to break the numbers down into their prime factorization. We did that a while back with factor trees. We said, okay, 24 is divisible by 2, and when we divide by 2 we get 12. And 12 is divisible by 2 and we get 6. And 6 is divisible by 2 and we get 3. And once we had that last number here is also prime, then we were able to stop. So this 24 breaks down into 2 times 2 times 2 times 3. We're going to do the same thing with 40. So 40 is divisible by 2, which gives us 20, which is also divisible by 2, and we have 10, which we can divide by 2, and we get 5. And again, we're now all down to prime factors, so we have 2 times 2 times 2 times 5. And then what we look for is matching sets. So we have a 2 in the top that matches this 2 in the bottom. And we have another 2 that matches this 2. We have a third 2 that matches this 2. We have a 3 in the top, but no 3 in the bottom. We have a 5 in the bottom and no 5 in the top. So what we're left with is 3/5. We're going to do the same thing when it comes to polynomials. It's just going to be slightly different because instead of just looking for prime numbers, we're looking for prime factors. So here's our example for that. To start with, we're going to simplify these. Okay, first we're going to write them in factored form, just like we did with 24 and 40. So the very first thing I see is 2x and 8 both have a common factor of 2. So if I divide the 2 out, I get x minus 4 here. And then 4x and 16 both have a factor of 4, which when I factor the 4 out, I get x minus 4. And what you'll notice is that we have matching factors now in the top and the bottom of x minus 4. Okay, and when those are actually divided out, that equals 1. And multiplying by 1 is doesn't change the fraction, so we're allowed to take it away. So what we're actually left with is 2 over 4, which we know 2/4 is the same as 1/2. So that one actually simplifies to 1/2. In the next one here, m plus 2 is as simple as that gets. Okay, but we can go ahead and factor like we did in the last video, this denominator here. So I need two things that multiply to negative 16 and add up to negative 6. And I'm thinking I can look at m minus 8 and m plus 2. Okay, you'll notice in the top and bottom we have factors of m plus 2 that match, so those divide out. We don't have any factors left on the top, so we're going to list that as a 1. And what's left on the bottom is m minus 8. So that's how we would simplify that one. In this third one here, we're going to factor the top. I need multiply to 8 and add to 6. So I'm looking at x plus 4 and x plus 2. And the denominator is already prime at x plus 4. And again, we have x plus 4 that matches. So in the numerator, we have x plus 2. In the denominator, we don't have anything left, so it's just 1. But usually if our denominator is 1, we don't write it. So there's my result of simplifying all three of those. Okay, so let's try something that's a little bit harder. Okay, let's move on to these three. Remember, at any time if you I went a little too fast, you can rewind, you can pause, you can do whatever you need to do. Okay, so in our first one, I'm looking at x squared plus 7x plus 6. I'm going to factor that, so I'm looking at x plus 6 and x plus 1, because 6 times 1 is 6 and 6 plus 1 is 7. In the denominator, multiplies to 12, adds to 8. I see x plus 6 and x plus 2. And I have matching x plus 6's, so what I'm left with is x plus 1 over x plus 2. And that's as simple as that gets. All right, so there's a little bit extra factoring I need to do in the next one. In the top, I see that everything is divisible by 2, so that's the first thing I'm going to factor out, is that common factor. I always have to look and see if there's a common factor. That gets me x squared minus 8, x squared minus 4x, actually, right? So let's erase that mark I made there. And let's write the right number in. So we have x squared minus 4x minus 12 after we divide everything by 2. And the bottom is still x squared minus 9x plus 18. Okay, so now I need to factor what multiplies to negative 12 and adds up to negative 4. I think I see x minus 6 and x plus 2 in that. And now I need two things that multiply to 18 but add up to negative 9. And I see x minus 6 and x minus 3. All right, so my matching x minus 6's go away, and I have 2 times x plus 2 over x minus 3. And that is as simple as that goes. Okay, so we can simplify rational expressions, which we're going to need when we multiply and divide them and add and subtract them.